All right, so here we are on a summary of trig. We're all the way to the end of our trig unit. I've had some technical difficulties today, so this is a bit of a test run with some new computer technology at the school. So, solving triangles. We have all the knowledge we need to find any side length or any angle in any triangle when we're given three pieces of information. The key now is to select the correct tool or the correct trig for each situation. The first question we ask ourselves, am I working with a right angle triangle? If the answer is yes, we have three choices for what we can use. First, the most obvious, if it's a right angle triangle, is our good old SOHCAHTOA, sine, cos, or tan. I wonder why that won't go away. Sine, cos, or tan. When we're using sine, cos, or tan, we're going to remember to choose the right one by labeling our triangle. So be sure to label your opposite, your adjacent, and your hypotenuse to choose whether to use sine, cos, or tan correctly. Remember, when you're using sine, cos, or tan, you can calculate a length or an angle. If you're calculating an angle, you always use the little -1. Actually, let's write that a little bit differently. So an angle, we'll always do inverse sine. It's called inverse sine, inverse cos, inverse tan. So that's the first thing we can do. If we have a right angle triangle, we can use SOHCAHTOA. For a right angle triangle, we can also use Pythagorean theorem. And that's the one where we talk about the side squared plus the side squared equals the hypotenuse squared. If we already know the hypotenuse, then we can subtract to figure out the side. So we can use SOHCAHTOA, we can use Pythagorean theorem, and finally we can use what we know about angles. The fact that the sum of the angles in any triangle is 180 degrees. So if you know two angles, subtract from 180 and find the third. So right angle triangle, SOHCAHTOA, Pythagorean theorem, and angle sum. If it's not a right angle triangle, then we have some different choices. If it's not a right angle triangle, we can still use the angle sum because all angles in every triangle add up to 180 degrees. So if you know two angles, you can always find the third. But we can't use Pythagorean theorem or we can't use SOHCAHTOA. No SOHCAHTOA, no Pythagorean theorem if it's not a right angle triangle. If it's not a right angle triangle, we need to think about the sine law. And we need to think about using the cosine law. Your job is to know when to use each one. To use the sine law, I always look for a pair. Look at diagram and look for a matching pair. That means you're looking for a side length and an angle that are across from each other. So you need to know a side length and angle that are across from each other or opposite each other, plus one other measure. So one other angle or one other side. And then you can use your sine law. To use your cosine law, it's a little bit different. Look at the diagram again, and to use your cosine law, there's two things you're looking for. If you know the length of all three sides, then you can use the cosine law if it's not a right triangle. Or if you have, or you know the length of two sides and a contained angle. That means an angle that is between the two sides. So, right angle triangle, use SOHCAHTOA, Pythagorean theorem, angle sum. Not a right angle triangle, sine law, cosine law, angle sum. Sine law you know to use. You have a pair, a length and an angle across from each other. Cosine law, all three sides, you know how long they are, or two sides and an angle in between. So we're going to do two quick examples, and then you've got some to do on your own. So when I look at the two examples, the first thing I look at, one's a right triangle and one is not a right triangle. For the right triangle, I can use Pythagorean theorem, SOHCAHTOA, or angle sum. So to use Pythagorean theorem, I would need to know two lengths, and I don't know two lengths, so I'm going to use SOHCAHTOA to start with. Here is my angle. This side is adjacent to my angle, and I'm going to calculate the opposite side. So opposite and adjacent is tan. So I'm going to go tan of 51 degrees equals the opposite side over 13.7. Now to calculate my opposite side, I'm going to do the opposite operation. So instead of dividing by 13.7, I'm going to multiply by 13.7. So that will give me 13.7 times the tan of 51. So 13.7 on my calculator multiplied by the tan of 51. And I got 16.9 meters. I'm just going to double check that because I think I might have pushed the wrong button just to be sure. Tan. Nope, I think I'm good. So there is the length of the opposite side. So to figure out the hypotenuse now, I can do trig again, or I could do Pythagorean theorem. I'm going to do Pythagorean theorem just to refresh our memories about Pythagorean theorem. So Pythagorean theorem is the side squared plus the side squared equals the hypotenuse squared. So to figure out my hypotenuse, if I square it, I know that it's going to equal 13.7 squared plus 16.9 squared. And I'm going to calculate that on my calculator. 13.7 squared plus 16.9 squared gives me a big number of 473.3, not 7. 73.7. I did it again. Third time's the charm. And then to figure out the hypotenuse, get rid of that squaring, I do the square root. So I now know that my hypotenuse is 21.8 meters long. And my angle sum, I know two angles. This one's 90, this one's 51. To figure out my third angle A, all I have to do, angle A, they all have to add up to 180. So take away the 90, take away the 51. So angle A is going to equal 49 degrees. And I've solved my triangle. I know all the side lengths and all the angles now. So for my non-right triangle, I know I can't use SOHCAHTOA. I look at the picture, and the first thing I notice about my picture is I have an angle that's between two side lengths. That means I should be using the cosine law, the angle between two side lengths, and the cosine law will help me find out the side across from the angle I know. So my cosine law, doesn't matter the letters, q squared is going to be 8.2 squared plus 14.2 squared minus 2 times 8.2 times 14.2 times the cos of 47. So I am going to do some calculating. 8.2 squared plus 14.2 squared minus 2 times 8.2 times 14.2 times the cos of 47. And I get a grand total of 110.06, blah, blah, blah. And I'm going to do the square root now on my calculator. And I'm going to get 10.5 meters. So I now know side Q is 10.5. At this point, I need to find out an angle. So I'm going to decide how to find out that angle. I'm looking at this and I see I now have a pair, an angle and a side that are across from each other. So I can use the sine law. I'm going to choose to use this side and this angle that are across from each other to do the sine law. Because I'm calculating an angle, I'll put the angle I don't know on top over the side across from it. And I'll put the angle I do know on top over the side across from it. And now I'll calculate my answer. So I'm going to end up calculating angle P by doing the sine inverse of what I started with, 47 divided by 10.5, and I bring the 8.2 over and do the opposite by multiplying, and I'll do the sine inverse of all of that to get my answer. So after having done sine law, you should be good at this calculation. Times 8.2. And I have got a grand total of 35 degrees. So I know now that angle P is 35 degrees. To find the last angle, R, I'm going to use my angle sum, subtract both the angles from 180. So 35 and 47. Angle R equals 180 minus 47 minus 35. And I'm going to get minus 47, 98 degrees. So I calculated all the angles and all the sides by deciding what trig to use based on the kind of triangle. That leaves for you guys, if you scroll down on the note, or sorry, go to the next page, 4 questions to try on your own. So make sure you've printed this note out, filled it in, and try those 4 questions.